Mhm. Okay, the first question is show work number 2 from 2021. Show work number 2. No. Just calculate integral. Okay. So the first step is to analyze what do we have here. It's an integral of rational function, which is actually good news. We know how we can integrate rational functions. We have algorithm to do the calculation. No need to improvise. Okay. And so after that, we have to check is given a rational function is a proper one or it is an improper rational function. And in this case, it is what? Proper or improper?
Not proper.
So we have to do long division. Otherwise, without long division, we cannot do decomposition. Decomposition will not be correct. Okay? So how we are going to do the decomposition? We have to long division. We have to divide x cubed by the denominator. So x cubed divided by keeping here multiplication is not so convenient. Maybe we can open brackets to see what's going on. If we do the multiplication, we'll get x cubed plus 5x squared. How many x's do we have? We have 4x and plus 5x, 9x, and plus 5. Is this correct? So if yes, then so formally we can process this long division, but otherwise we can just simply add 5x squared plus 9x plus 5 and subtract it from our numerator, and we will get, so imagine we are adding 2x cubed 5x squared plus 9x plus 5, and we are subtracting it. So we'll get 1 minus 5x squared plus 9x plus 5 divided by the same denominator, x plus 1 times x squared plus 4x plus 5. Do you agree with this? If yes, let's move forward. And now we can just consider two simple integrals, integral 1 and integral of another rational function, which is now already a proper one. So integral of 1 gives just x. We have to subtract. Look, I'm not writing plus c because we have still remaining definite integral, indefinite integral, and indefinite integral contains this plus c component. So 5x squared plus 9x plus 5 divided by x plus 1, x squared plus 4x plus 5 of x. Okay, now let's do the calculation of this integral separately. We can do decomposition. Or before doing decomposition, let's check. Do we have x squared plus 5x plus 5 irreducible quadratic equation, or we have other real solutions? And of course, calculating discriminant, we will get that no, we do not have any other real solution. Hence, we are ready to do decomposition. We can write it as a divided by x plus 1 plus bx plus c divided by x squared plus 4x plus 5. Where what we can say about a, b, and c, let's do the calculation on this right side. When we bring it to common denominator, we'll get a multiplied with x squared plus 4x plus 5 plus x plus 1 is multiplied with bx plus c equals to 5x squared plus 9x plus 5. Do you have questions? If no, let's solve this equation. What can we do? One simple step, we can plug x
Minus
equals to minus 1. Great, yeah. If we plug x minus 1, x plus 1 is 0. Hence, we'll get just x squared minus 4. So 1 minus 4 plus 5, it gives 2. 2a equals to 1. So we have calculated value of a 1/2. Next, for example, we can open brackets and say that a plus b equals to 5. The coefficient of x squared should be 5. Or we can just plug another constant, like plug x equals to 0. We'll get 5a, so 5/2. If x is 0, we'll get x plus 1, 1 times c, so plus c, equals to 5. Hence, c also is 5/2. Right? And finally, to get b, if we open brackets, a plus b is the coefficient of x squared equals to 5. So a plus b is 5. A is 1/2, so b is going to be
9/2.
9/2. So we can write our integral as a over x half. A is 1/2. Let's put 1/2 here. 1 over x plus 1 d of x plus bx plus c. Let's take 1/2 just outside from our integral. And it remains 9x plus 5 divided by x squared plus 4x plus 5, which, of course, you know that next step is to complete square. From the beginning, let's write it as x plus 2 squared plus 1. Do you have questions? So if no, let me erase this part. And the integral of 1 over x plus 1 is straightforward. What about 9x plus 5 over x plus 2 squared over 1? We can split this integral into 2 parts. We can, okay, let's write 1 over x plus 1 as logarithm x plus 1. And for the second term, we can just add and subtract 2, right? So we have logarithm module x plus 1 half plus the second integral. I just suggest to write, we can do x plus 2 denoting, we can denote by u, or we can write 9 times x plus 2. If we open brackets, we'll get 9x plus 18 minus 13 divided by x plus 2 squared plus 1. Do you agree with this step, guys? 9x plus 5 can be written as 9x plus 2 minus 13. Why having this is helpful? Because we can now calculate the integral of 9 times x plus 2 divided by x plus 2 squared plus 1 as what? How we can calculate this integral?
We can denote x plus 2
Yeah.
by u.
X plus 2. We have a bit better substitution. X plus 2 squared.
Not squared of u.
Let's denote by or plus 1 also. And we'll get 9 times at the end, if we do the calculation, logarithm x plus 2 squared plus 1. Right? Divided by 2 here. And finally, we have 1 over x plus 2 squared plus 1. What about this integral? 1 over x plus 2 squared plus 1.
It's arctangent.
Arctangent what?
X plus 2 over 1.
Arctangent x plus 2. Yeah. Arc tangent x plus 2. Okay, C2, C1. And it remains to plug everything to get our final result. So final result, we have x minus. So here we said we have 1/2. So 1/2 logarithm x plus 1. Then we have plus 1/2. So plus 9 over 4. 9 over 4 logarithm x plus 2 squared plus 1 and minus 13 over 2 minus 13 over 2 arc tangent x plus 2 plus c. Is this okay, guys? So the main here step that we have to be careful at the beginning, long division was needed. Okay? Yes. Do we have other questions from 2021? Let me just go through quickly. No, 2021, this was the only question. Now let's move to 2024. The old one means maybe which was uploaded earlier. And question is multiple choice number 5. We have given function f, and our goal is to understand for which value of a, here we have a limit. Okay, for which value of a, function f has limit at 0 point. Function f has limit at 0 point if limit from right side and left side, right and left, we are equal. So limit as x approaches to 0 from the right side. On the right hand side of our function of 0, our function is defined as root of x divided by root of 16 plus root x minus 4. We can try some naive approach and plug x equals to 0 and we'll get 0 over 0 form. Okay, if it is 0 over 0 form, so in that indeterminate form, what can we do? Any other solution? Like,
Multiply with conjugate or L'Hopital.
yes, which one is better? What do you think, L'Hopital or conjugate? Yeah, I agree. Conjugate. Yeah, seems to be better approach. Root of x times root of 16 plus root x plus 4 divided by, so squared of the first root, 16 plus root of x minus 16. It remains just root of x, which will be cancelled with the remaining root of x. Plugging 0, we'll get 8. Now let's do the calculation from the left side. X goes to 0 from the left side. Our function has 1 minus cosine ax divided by x squared. If again we plug 0, we'll get 0 over 0. So what can we do?
It's gonna like minus utgangspunnen.
G minus wordt er iets.
Haitararit.
I don't make squared of this, which is 16. So 16 plus root x.
Half, ja, 6 halashakenek.
Okay. So kijk, yes, kan opschrijven. Laten we smeken van zijn hashform from left side.
L'Hopital.
L'Hopital, yeah. Do we have any alternative approach?
Cosine-ով ինչ-որ բանաձև օգտագործել։
Կարանք, we can multiply and divide by 1 plus cosine ax, and we'll get 1 minus cosine squared formula, giving us sine squared, and then we have useful limits, or applying L'Hopital. And we have already verified that it's 0 over 0 form. Derivative of 1 minus cosine ax gives a times sinus ax divided by 2x. And let's multiply and divide by a squared here, a here, sinus xa over xa tends to 1 by our useful limit. And it remains a squared over 2, for which a squared over 2 equals to 8. We have 4 and minus 4. But this we have to circle the right answer, not put it on the inside of some irregular shape. I since circled. Questions? Let's move forward. 2024 show work number 5. I'm not sure we are talking about the same 2024. Before moving that, we have multiple choice number 2 from this year. G of x is one of antiderivatives of our exponential x over x. By the way, can we find g of x explicitly? Can we do the calculation and find g of x? Can we integrate exponential x g of x? Please check that actually it's hard to get g of x calculated explicitly and expressed in terms of finite combination of alternative functions. It doesn't work, so let's continue to read our exercise. Okay, even though we don't know what is g of x explicitly, but our goal is to calculate f prime x, derivative of this function. And when you have function taken another function power, we can apply logarithmic differentiation formula, which says that derivative of function can be calculated by getting the derivative of logarithm f and then multiply with f of x. So let's keep this four answers. All of them have this f factor, and focus on the derivative of logarithm f. What is the derivative of logarithm f? Logarithm f is so to the calculation is g of x times logarithm x, and we have to calculate derivative of this. And applying here formula for the multiplication, we'll get derivative of g. Derivative of g is given is ex over x times logarithm x plus derivative of logarithm times g of x divided by x. And it seems that B is the correct answer. Right? Questions? If not, let's move forward. We have from 2024 question, again, multiple choice number 6. Okay. X0 is a critical point of function f. Critical point means either derivative of function at x0 doesn't exist, or derivative is 0. Okay? Then which of the following is true? And it seems that the first statement A is correct, because if we think of function g of x, which is x minus x0 squared times modulo f, this function is always non-negative, right? We have some squared times modulo, it is never 0. It's never negative, it's non-negative function. And it's easy to see that at x0, value of our function is 0, right? If you plug instead of x0, we'll get 0 due to this x0 minus x0 squared part. Now, if we have a function which is always greater or equal than 0, and at some point x0 it is 0, x0 is global minimum point of g. You cannot get anything smaller than 0. So x0 is global minimum. If you have global minimum point, Fermat theorem says that it should be a critical point. It should be a point where, derivative of g is 0. Either derivative of g is 0 or derivative doesn't exist, right? For both cases, we have a case when x0 is a critical point. Once again, if you have global minimum, global maximum points, at these points are critical points for sure. That's the reason that we can just circle A. Why remaining answers are not correct? Like, okay, for B, maybe, okay, function at x0 is critical point, and what if, okay, it's a critical point, but multiplying with x minus x0, it's not anymore minimum, maximum, or whatever, like imagine we have insurance acting. F is a constant function. Derivative at every point is 0, right? So in particular, when f is constant 1, for constant 1, any point is a critical point. But here, x minus x0 is not anymore a function which critical point is x0.
Իսկ
And
եթե
C,
մի հարցելի, եթե definition-ը օգտագործենք բանի, անցանցյալի որ
okay.
լիմիտից x-ը ցկտում է x0-ի,
Why definition? Even without definition, we can take derivative of this product, right? And formula for the multiplication says derivative of the first part times f at point x0, ha x0 ben ha shun asansörle çe, and plus x minus x0 times f prime at x0, and here also plugging x0, this term will be 0. But we have fx0 term, and who says fx0 is 0? There is not any information about value of function at x0. So derivative is not necessarily 0. It is fx0, not 0. Huh? Again, here we can apply if we know that derivative of function exists. But who says function is differentiable at x0? There's not any information about being differentiable at x0. So C also we are dropping because maybe derivative doesn't exist. And D, E obviously are wrong statements because no any information about function at 0 point. When we plug this of x0, we'll get something about function at 0 point, no any information whether 0 is a critical point of our function or not. Hence, D, E are obviously wrong. So once again, A is correct answer since x0 is a global minimum point. And for B, x0 is not anymore global minimum point. Love? Okay, that was number 6, 10. Multiple choice number 10 from the same year. Graph of the derivative of our function. So here we have a graph of f prime. Based on this information, how many inflection points does function f have? Okay, how from graph of f prime we can understand inflection points for function f?
Maximum, minimum points.
Yes, extrema points for f prime are inflection points. 1, 2, 3, 4. Here I cannot find anything spatial. One, 2, 3, 4, 5, 6. Am I right that we have 6 extrema points? It seems we have 6.
May I
And
ask a question?
yes, go ahead.
It is the graph of the derivative of the function. If we had king points here, would they be considered as inflection points or dead points if the second derivative doesn't exist? We won't consider it?
If we have a king point, then for all like graphs that you can imagine, all king points are sort of minimum or maximum points. Then if f prime has a king point, that point is an inflection point. Okay, second derivative doesn't exist at that point. But inflection point is a point where
it changes concavity, yes.
Right, and we do not have any condition that function should be twice differentiable at this point. We need to know that function is continuous at point x0 and concavity changes passing through point x0. Then it is the inflection point, which is translated into f prime, that f prime, the extrema points for f prime are inflection points. And if you have king point, whatever is the graph here, king point is going to be local minimum or local maximum. Hence, it is going to be inflection point.
Okay, thank you.
Thank you too. This was from 2024 multiple choice questions. We have also questions about some show work problems from this test. Show work number 1, 3, and 5. Okay, the first one. Main step here, guys. Whenever you have sinus something written as argument, you should think of denoting this as u. To get sinus u. Maybe for this particular case, having log x plus 3 denoting by u also is a good suggestion, which, yeah, I agree. Maybe we can do logarithm x plus 3 is u substitution, which means like 1 over x plus 3. If you prefer, you can push under D and get this substitution. So how we can perform logarithm x plus 3 is u substitution. We'll get 5u plus 1 multiplied with sinus 3u plus 2 du. Do you agree with this? If yes, how we can calculate this one? 5u plus 1 times sinus 3u plus 2. The trick is integration.
IBP.
Yes, IBP, integration by parts. Sinus can be written as derivative of minus cosine 3u plus 2 over 3. And doing integration by parts, we'll get minus 5u plus 1 times cosine 3u plus 2 divided by 3 and plus 5 over 3 integral of cosine 3u plus 2 du. And here we have minus 5u plus 1 multiplied with cosine 3u plus 2 divided by 3. And the integral of cosine is just sinus. So we have 5 over, we should write 9, right? Sinus 3u plus 2. We have written here 9 because the derivative of sinus 3u plus 2 is not just cosine, but 3 times cosine. By chain rule, we have multiply 3. So we are dividing by 3 to get rid of this, plus c. And of course, this is not the end of the exercise, right? We have to go back to x variable. Instead of u, we have to plug logarithm x plus 3. 5 times this. So I'm leaving you to complete the exercise. Just rewrite everything you replaced with logarithm x plus 3. Questions? No, let's move forward. The next exercise from this test is show work number 3. Yeah, this one. Okay, guys, if we just pass to the limit, x is 0, sinus 0 is 0, cosine of 0 is 1. We'll get 1 minus 1, 0 over 0 form, plus 1 over 0. And we can say, okay, what if we calculate this term separately and this term separately? It's not a safe approach because what if we get like minus infinity plus infinity form? So let's do not split into 2 parts and do calculation for this form. So what can we do? We can bring into common the numerator. Limit x goes to 0. The numerator is x squared, and numerator is going to be cosine sinus x minus exponential x plus x. Plugging 0 will get 0 over 0 form, right? And guys, please verify that it is 0 over 0. Cosine of 0 is 1, 1 minus 1 is 0, plus 0. So let's do L'Hopital. Limit x tends to 0. Derivative of cosine sinus x. Chain rule is needed. Derivative of cosine is sinus. So sine x. Derivative of sinus is cosine. Minus exponential x plus 1 divided by 2x. We can plug again, x is 0, we'll get sinus is 0. So times cosine is still 0. -1 plus 1, 0 over 0 form again. So another let's check them. Aneng, again 1. No, let's do not do. Sorry, I wanted to do L'Hopital, but let's be here a bit smarter, and instead of doing another L'Hopital, which will require us to calculate the derivative of sinus x times cosine, which is of course not very complicated thing, but let's split this into two limits. Minus sinus x. Will be nice if sinus x is divided by sinus x. Then we can simply apply useful limit. But unfortunately, it is not divided by sinus x. So let's multiply and divide by sinus x. It was divided by 2x and times cosine x. Right? And let's write the remaining term exponential x divided by 2x. What do we have here? Useful limit here. This goes to 1. Useful limit here. Again, it goes to 1. Cosine goes to 1. Exponential x minus 1 over x goes to 1. So combining all this stuff together, we get minus 1/2 minus 1/2. It's minus 1. Do you have questions? No, let me. Sorry. Let me go to the next question. 2024 show work number 5. Okay, prove the inequality. X plus y squared times logarithm x plus y over 2 less than or equal to 2 times x squared logarithm x plus y squared logarithm y. Okay, guys, proving some inequality. Help me. What do we know? Which methods can be applied to obtain some inequalities like this?
You need to find the function.
Find a function for which. What are we going to do
Can
with
we
function?
use the definition of concavity?
Okay, one approach is to use the definition of concavity, which is correct suggestion here. In general, maybe mean value theorem also can be used to get some inequalities when you have x, y variables, right? In this case, but I agree that most probably here we are talking about concavity of some functions. So what is very natural choice here to consider f of x is x squared times logarithm x. First of all, let's understand the concavity of logarithm x when x is greater than 1, right? Our domain is xy greater than 1. So let's consider function f for x is being greater than 1. What is first order derivative of f? So multiplication, derivative of x squared to x logarithm x plus x squared times 1 over x. So x taken into common 2 log plus 1. Double derivative. Again, multiplication, we'll get 2 logarithm x plus 1. Then taking derivative of 2 logarithm x plus 1, we'll get 2 over x, so plus 2. Am I right here? 2 logarithm x plus 3 is actually strictly greater than 0, right? Because x is greater than 1. For an x greater than 1. Okay. Next, we can say that this implies that f is concave up. And the definition of concave up functions is that f alpha x plus 1 minus alpha y is smaller than or equal to alpha f of x plus, here we have given not strict inequality, so I'm writing here not strict inequality. 1 minus alpha f of y. Here, this inequality holds for any alpha from 0 to 1. Now our goal, last step, or almost last step of this exercise, identify alpha for which we'll get something very similar to given inequality. What are we choosing as alpha?
Make a group.
Let's try. Let's try to take alpha is 1/2. So alpha 1/2 means fx plus y half. I'm just writing fx plus y half less than or equal to f of x plus f of y half. Now finally, let's replace our function f with x squared times logarithm x. So we'll get x plus y squared half times logarithm x plus y half smaller.
Դեպք պետքա 4 լինի։
Քառակուսի մեջ պետք է այս փագիծը կամ ներքև կամ sense. Thank you. You are right. Կամ փag squared is about x plus y, so yeah. Smaller than fx, so x squared ln x plus y squared ln y over 2. If we multiply both sides of this inequality by 4, we'll get exactly our inequality. Right? This is the same as our equation number 1. Right? Just multiply by 4, x plus y squared times logarithm x plus y half less than or equal to 2 times x squared logarithm x plus y squared logarithm 1. And yes, indeed, we get it. The toughest part of this exercise was to identify function f for which we are going to apply the definition of concavity. Okay? And we are done. Questions? Okay. The next test that we will tackle maybe 2023. Okay, multiple choice number 5. Which of the following sequences is divergent? At first glance, A has 3 different subsequences, but okay, every third term is 0. Then if you focus on 1, 1/2, 1/3, it seems it also decreases to 0. And also, if we just consider 1/2, 1 divided by 2 squared, 1 over 2 cubed, also this term tends to 0. So here we have a sequence that tends to 0. But for sequence B, the first elements are 1s, and second elements or even terms are 1/2, 2/3, 3/4, and it also tends, it's like n minus 1 over n goes to 1. So A is convergent. B also is convergent because it tends to 1. What about C? When n tends to infinity. 4 over n goes to 0. Sinus at 0 is 0, which is multiplied with sinus n over 4. So it is 0. The last one tends to 0 as well, because here we have n squared and numerator is of order n. And only statement sequence D here is divergent because it follows to cosine n pi over 4. It is periodic. It has 4 subsequences with at least 2 different limits. If we do the calculation, we'll see that every 8th term here is getting repeated. And most probably, if we denote this xn, we can just consider x 8n or 8k, and x 8k plus 1 will get 2 different limits. Okay, so this is divergent, D is divergent, hence it is the correct answer. Questions? Let me move forward from the same year, multiple choice number 4. Let the function f be twice continuous differentiable function, which the following statement is impossible. Function positive, increasing and concave up. Positive function increasing concave up. Well, it's possible. It's possible. We have such examples. Exponential minus x is such an example. So A is wrong. Function now is positive. It is decreasing and still concave up. Like this. Why not? Minus terms. E to the power of minus x, like this. Positive, concave up, and decreasing. So let's eliminate this one as well. Now we have negative function, decreasing, and being concave up. Negative function, it gets smaller and smaller and smaller, and it is concave up. Something like this. Is it possible to get some function like this? Here, the main issue that it seems at some point it will intersect x-axis. Let's come back to this statement C a bit later. What says D? D says negative, decreasing, concave down. Yeah, it's easy. Like this. So for sure, it's not correct answer. And E, function is increasing, negative, and concave down. Yeah, again, we can rotate this previous picture like this. It is increasing, concave down, and negative. So it remains only statement C. Now let's elaborate more. Why this is impossible? Why we can't have function that is decreasing, concave up, and negative? Why it is impossible? The maybe simplest way to see that this is the case is to say, okay, what's going on with tangent lines at this point. Like function is differentiable, that's why it has tangent line. And the slope of the tangent line is going to be negative, right? Because we have this condition, derivative is negative, so the slope is going to be something like this. Imagine this is in black, we have a line, tangent line at this point. Now this line has negative slope. It's going to intersect for sure our x-axis, right? We are going to have some intersection here. Moreover, our function is concave up, which means our curve is going to be greater than tangent line. Hence, it is going to intersect x-axis as well, which contradicts to this part. So C is impossible. So maybe it is easier to construct examples for previous statements are possible to construct functions, and here the rigorous way to justify that is impossible, maybe is tangent line is easiest way. Questions? What do we have else from this 2023 year? Multiple choice number 2 also. I skipped that one. Let's go back. Given function f, which of the following statements is true? Which of the following statements is true? Okay. Function f has a limit at 2 for any a. Let's calculate the limit of function. If it's about limits, okay, let's see what is the limit of our function at 2. Okay. How we can find limit of our function? Do we need to consider sided limits here? Guys, do we need to consider sided limits?
No, because from left and right,
It seems on both sides our function it behaves same way, but be careful. What is the limit of 3 to the power 1 over x minus 2? Okay, what is the limit of 1 over x minus 2? If x tends to 2.
In this case, if it tends to from right, we get a positive infinity, and from left, negative infinity.
Right, and it is super important. 3 to the power of plus infinity is plus infinity, and 3 to the power of minus infinity is 0. So we have to calculate limit from right and left. And from right and left, we are going to get 2 over infinity case, which is 0, or 2 divided by 1, which is 2. Okay, so function has limit at 2 is wrong. It never, it doesn't depend on value of a. And a here is not important. Limit here doesn't exist. Because limit from one side, from right side, is what? Limit x tends to 2 from the right side of our function f is going to be, let me write like this, 2 over 1 plus 3 taken to plus infinity, which is 0. And limit from left side is going to be 2 divided by 1 plus 3 taken to minus infinity power, which is 2. 0 from one side, 2 from the other side, limit doesn't exist. If a is 0, f is continuous. No, we said that limit doesn't exist, so it can't be continuous. If a is 2, then f has removable discontinuity. No, for removable discontinuity, we have to get two limits from both sides. F has jump discontinuity, Yes, it is. Essentially discontinuity, no, because limits from right and left are finite, 0 and 2. So D is the correct answer. Questions? Okay, what do we have else from 2023? We have show work number 1. Okay. Calculate this integral, and can you help which substitution we have to do here?
Square root of x.
Okay, square root of x. Can I denote square root of x plus 1 by you?
Yeah, it's the same thing. It's divided 1 over square root of x.
Right. And derivative of root of x plus 1 is 1 divided by 2 root x d of x is du. Okay. We have d of x divided by root of x component, which is going to give us du times 2. So doing that substitution, we'll get 2 integral u times log u du. Okay. Next is what? One's hash length, u times log.
IDP.
Yeah. Integration by parts by writing u as derivative of u squared over 2, or pushing u inside 2 inside, and 2u is u squared prime. So we get u squared times ln u minus u squared times derivative of logarithm 1 over u du. So u squared logarithm u minus integral of u squared half plus c. And the last step is to plug, instead of u, root of x plus 1, root x plus 1 squared logarithm root x plus 1 minus root x plus 1 squared over 2 plus constant c. Okay? So we are done. What do we have next? Next, let's go to the top of the chart. We have 2020. Okay, 2020. Multiple choice number 6. It's given function, and pay your attention, function is given through some implicit way. It's not an explicit way. Okay. Or why? Okay. We have to find the equation of tangent line. Okay, let's do it. To find the equation of tangent line, we have y equals to slope, the derivative, at which point we have to find at x0, times x minus x0, plus value of our function at x0. Okay, let's begin with the calculation of y x0. What is the value of y at x0? Let's plug into our equation, plug x0 equals to 1 into r1. What we'll get? X minus 1 is 0. So we'll get 4 equals to 1 plus y at x0. So y at x0 is 3. It doesn't mean that we have to drop C and D. Maybe C and D still are correct. Just value of our function 3. Now let's calculate the slope of this function. To calculate slope, we have to calculate derivative. So let's take derivative of the equation number 1 from both sides. Derivative of x minus 1 is 1, so we'll get e to the power of y plus x minus 1 times ey times y prime equals to 1 plus y prime. And again, plug into this equation x equals to 1. What do we get? We get e to the power of y, and y we have calculated is 3. So e cubed. X minus 1 is 0 equals to 1 plus y prime at 1. So y prime at 1 is e cubed minus 1. So let's write the equation of tangent line here. We'll get y equals to e cubed minus 1 multiplied with x minus 1 plus 3. Now let's try to find the correct answer, which seems to be this. Okay? What do we have from this year? We have multiple choice number 8 as well. F 2 times differentiable is continuous on some interval, and some f minus 5 equals to f minus 3 equals to 4. F0 is minus 2, F2 is minus, okay, some conditions are given. Which of the following statements is true? And statements are about inflection points. Okay, one approach, guys, to solve this type of exercises is to try to sketch graph of function f. For me, I have to try to write straight lines, plot straight lines, and then, okay, f minus 5 and minus 3. Minus 5, minus 3, value of our function 4, then minus 2, then 1 and 1, and minus 2 and minus 2. Somehow we are going to join these points together. Something, yeah. Okay, like this, like this. Okay, so it shouldn't also like this, but at this point, the tools that I have with me are not allowing me to plot nice graphs. Okay, how many inflection points do we have? Like here, function should be concave down, and then it turns to concave up here. So in between, we have for sure here one inflection point. Then from concave up, it turns into concave down. So we have somewhere here another. And at the end, repeating the same stuff, in between, it has x3. So it seems we have at least 3 inflection points, maybe more. Maybe more because we don't know what's going on in between minus 5 and minus 3. Maybe our function changed the concavity 5 times. So at most answers you should eliminate from the beginning. It's impossible to have. And it seems we have at least 3 inflection points. Concave down turns into concave up into concave down into concave up. So the easiest way to solve this type of exercise, guys, put points, join these points together through some not very strange curves. In my case, it is super strange curve, I agree, but I cannot do anything better using my marker here. Okay,
May I ask a question?
please.
It's not, it's kind of related to this. I just wanted to confirm. If it says the function is differentiable on R, it means that the function doesn't have critical points, right? So everywhere.
No. If it is differentiable, maybe derivative is still 0.
I'm sorry. I meant its derivative always exists. So
Right.
its critical points are only the points where the derivative is 0.
I agree.
Yes. Okay, thank you.
Moreover, so it means it has, for example, no any discontinuity point. That's true. But also, if function is differentiable, the only way to find critical points is to find zeros of derivative. We do not have any other critical point. In general, we might have critical point where function is not differentiable, not the case when it is given opposite.
All right, thank you.
Show work number 5 from this year. Find concavity intervals of the following function, which means we have to calculate second order derivative. Let's begin with the calculation of the first order derivative. What is f prime x? Product, so let's use formula for the multiplication. Derivative of x to the power of 5 over 4 is 5 over 4. X taken to the power of 5 over 4 minus 1 gives minus 1 over 4. Sorry, plus 1 over 4. Times exponential minus x and plus x to the power of 5 over 4 times e to the power of minus x. Here we can simplify a bit and take e to the power of minus x into common. Minus բացեմ թողել.
Եի minus x-ը որած անցենք minus
You are
1-ը
right.
լաստ։
You're right. Thank you. Here we have minus. Yeah. Taking exponential minus x into common, we'll get 5 over 4 x 1 over 4 minus x to the power of 5 over 4. Of course, x to the power of 1 over 4 we can take into common, but since we are going to calculate second order derivative, maybe it is easier to calculate derivative for this form. So again, product, yes, let's use the formula for the multiplication once more. E to the power of minus x times derivative here now we'll get 5 over 16 x to the power of minus 3 over 4 and minus 5 over 4 x 1 over 4 power and minus e to the power of minus x 5 over 4 x 1 over 4 minus x to the power of 5 over 4. Now taking e to the power of minus x into common, we'll get 5 over 16 x to the power of negative 3 over 4. How many x to the power of 1 over 4 do we have? We have minus 5 over 4 plus 1 plus 5 over 4, right? X to the power of 1 over 4s are cancelled out. And it remains also plus x to the power of 5 over 4. Is this correct? If yes, let's take
Under minus încă plus ităvă.
Andera
Double derivative match. Comparație minus x asta ce.
Չեմ գտնում մի հատ օգնեք էլի։ double derivative
Որտեղ
exponent.
մտնիկն է հենց,
Այստեղ։
հենց a-x աստիճան անգամ փակագծել, հետո գումարացել a-x աստիճան, որտեղ sense մինուսով cancel
Գումարած, չէ, գումարած պետք է գրենք, բայց j-x-ի վրա տանցիալը հաշվում ենք, we get another minus. So this minus comes from the derivative of exponential minus x.
Եթե տենց աչքս անում, 2 հատ 5 4 անգամ x.
Չէ, ինքնամ ստեղ մինուս է, maybe you are right, but here we have minus sign. Minus is correct, but you are right by saying that I have to write what 2 times, so minus 10 over 4 x to the power of 1 over 4, like this. So դա եք ասում. Now let's take x to the power of minus 3 over 4 into common. Let's take x to the power of minus 3 over 4 out. 5 over 16. So 5 over 3 minus 3 over 4 is going to be x squared. And minus 10 over 4 x. We have this. So let me just write double derivative here and erase everything else. We have e to the power of minus x times x to the power of minus 3 over 4. And maybe we can take 1 over 16 into common, and we'll get 16x squared minus 40x plus 5. And then we have to find in which intervals this double derivative is positive, in which intervals it is negative. To do this, it's easier first to find zeros of this double derivative. And to find zeros, we have to solve this quadratic equation. 16x squared minus 40x plus 5 is 0. Can you help me by solving the equation while I'm erasing this? Squared minus 40x plus 5 is 0. What's our solutions?
The solutions are 1.25 plus minus square root of 5.
Something like this.
Yes, I got something like that.
Okay, that's fine. And the second one doesn't belong to the domain from 0 to plus infinity. Hence, we have only one potential inflection point, 1.25 plus root of 5. What is the sign of our double derivative? In between of two roots, polynomial is negative, so it's going to be minus and plus. So function is concave down from 0 to 1.25 plus root of 5, and concave up from 0 to from 1.25 to plus infinity. Here you can consider closed or open intervals up to you. 1.25 plus root of 5 to plus infinity. Here it's concave. And yeah, this point obviously is an inflection point. Inflection point. Questions? Do we have questions from this test? Let me just go through quickly. We are done. 2020. Show work 3. Yeah, show work 3. Okay, this is very, very similar to the one that we did with L'Hopital rule. We have to first bring into common denominator. So, we have here limit log 1 plus 2x minus x minus sinus x divided by log 1 plus 2x times x plus sine x. Of course, we can apply L'Hopital at this stage, but I would prefer to write the numerator as multiply and divide by 2x. We'll get 2x divided by log 1 plus 2x. X plus sinus x, again, let's multiply and divide by x. X over x plus sinus x. And multiplied with log 1 plus 2x minus x minus sinus x divided by, so we have multiplied 2x, so here we have 2x squared. And to calculate limit of this term, please do 2 times L'Hopital. Here limit is 1, and limit of this part is what? What's the limit of x over x plus sinus 1 sinus x? 1/2. Just divide numerator denominator by x, we'll get this 1/2. And I'm leaving the calculation L'Hopital. It is now straightforward. 2 times L'Hopital of very simple terms is going to give us some finite limit.
Մի հատ հարց կարող եմ տալ։
Իհարկե։
Այդ ամենաառաջին քայլով ինչ է կարել։
Ընդհանուր հայտարարի են բերել։
Հա, դրանից հետո
Դրանից հետո հայտարարի լոգայթ 1 գումարած 2x-ը ու x գումարած sinus x-ը useful limit-ների շնորհիվ ուզում եմ ազատվեմ. So we are multiplying and dividing by x or 2x and x. We just multiplied and divided by x and 2x. Why so? Because it is more convenient to keep on the numerator instead of a log times x plus sinus x. It is preferable. It's much better to have not this term, but have here 2x squared for L'Hopital is much more convenient, right?
Merci շատ։
Of course, you can do L'Hopital even after this, like bring common denominator and do L'Hopital. Again, it will work, but much easier to replace multipliers with some x powers and then apply L'Hopital rule. Okay, the only question here on our chat remains from 2025 multiple choice number 5. 2025 fit tested SR9. No, I'm kidding. Okay, dear guest, we can discuss it next week. Do we have other questions? If no, guys, the test for tomorrow is not going to be complicated. Take your time. You are going to have 2 hours of working time. So, well, enough time. Do not stress. It's not complicated. Do your best. Enjoy the exam. And good luck. Okay, see you tomorrow.